think I'm good.
I think that's the right height.
I'm pretty close.
Yeah, yeah.
I don't know, a minute. Is it doing anything?
Yeah.
Woohoo! I think it will give us the average when we stop.
Yeah, it seems like the pole is kind of oscillating.
Oh, I see.
I'm comfortable. You can do as long as you want. I would like to go home when it gets dark.
All right. I think that's well, we have 50 seconds, so we can wait for more.
I can wait. It doesn't seem like that long until you're hanging off a bridge for a minute.
All right. Stop. Done. Well, great. Grab that.
You don't mind. Box is hanging. Okay. So a couple of questions that were in the lab to ask about some things that you can see. One of the questions is, do you think the stream is eroding, or I think it's depositing, or what's going on? Is there active erosion here? And there's actually not too much erosion because the water comes to the banks and there's vegetation that grows right down to it. There's not a lot of bare sediment exposed, so that indicates that there's not a lot of erosion. Another question asks, when you look at the floodplains or the banks of the rivers, is there any important aspect or important constituent of the main vegetation that's missing? And if you look around through here, what you see is there's not a lot of pine trees or evergreens. There's a couple over here. If you zoom in, there's a couple over there, but when you look at them, they're up on higher elevation. And there's a couple over on this side, and they're also at higher elevation. Pine trees don't like to get their feet wet. It would be almost like the same as asking one of you to stay here, standing in the water up to your knees until we came back tomorrow and picked you up. Most people would not be too excited about doing that. So pine trees like well-drained soil. They're usually up on higher elevations. The water goes down through the sediment. It's porous and permeable, so the roots stay relatively dry. Most of the vegetation that you see here is related to species that enjoy having a lot of water and having their roots go right down into the saturated substrate. Another question asked is, do you think the stream is doing a lot of erosion at this particular time? And like right on adjacent sides of my shadow down there, you can actually see the bottom of the stream. And one of the things you think about, as the stream does more and more erosion, it picks up more and more sediment. So consequently, as it does that, it would make the water cloudy. All the sediment would stay in suspension, and consequently, you wouldn't be able to see clear water. Another question it asks is, how come the water's brown? If you look at the water here, the water's brown. And it's not due to suspended sediment, it's actually due to material that's dissolved in the water. Every year in the fall, we lose all the leaves on the trees. As you can see around here, the trees' leaves are lost. They go down onto the ground, they decay, and the dissolved material ends up in the stream. And that brown color is a result of a variety of things dissolved in the water. Basically, they're all lumped together as tannic acid, TANNIC. And tannic acid, we might ask, is it good for you? Is it bad for you? Well, if you'd been on this field trip today, you might go home this afternoon and make a nice cup of hot tea. And what do you do to make hot tea? You take a tea bag and put it in hot water, and all of a sudden the water turns brown. Effectively, you're leaching the tannins out of the leaves and the tea, and then you drink that. So it's probably not a bad thing. It does increase the acidity of the water, but it's natural acidity. It doesn't really cause any big problems. I think that covers all the questions at stop number 1. Okay, so now a little terminology about streams. And what we're going to find out is that the area where the water flows, that U-shaped structure that actually contains the water, we call that either the stream bed or the stream channel. And you can see where the boundary is. It's on the left-hand side over here, and on the right-hand side over here. And underneath, we assume it makes a nice U shape. If we drained out all the water, ultimately what we would see would be a U-shaped channel. Now here it would be generally gradual, and what we'd also find is what you also found when you measured the depth was that as you measured the depth, the numbers got bigger, or the depths got greater, and then they got smaller. So our channel kind of looked like that, a U shape. And what we're going to find out is that's correct. Now right near the edge of the channel, water sometimes spills over. Like, this is a good time of year to be looking at this, because too much water comes into the stream. Where does it go? It spills over its banks, and the river actually gets wider. And the width of the stream is actually what you can see here when we have maximum capacity. It's all this flat area that you see on either side of the channel. And going from here to here, the channel becomes way larger. So what might you expect to happen to the velocity when the channel gets way bigger? Well, we have a bigger channel, so what actually happens is the velocity of the stream goes down. And so consequently, the stream slows down. And when it does that, when it spills over onto this big flat area, and that would be the next question, what do we call that big, broad, flat area adjacent to the river? We would come up with the answer, floodplain. And floodplains are pretty common geologic features. They're the flat area that's produced as the stream meanders back and forth across the stream valley. And what it does is it erodes material and deposits it. And this is a really good place to take a look at that, because if we look in the distance, if I zoom in, you can see a really steep bank on the backside of the curve of the river here, on the outside curve. You can actually see the path of the current going right through here and then around the bend. And in the process there, the material's eroded off the outside of the curve. That's called the cut bank, where erosion takes place. And it's deposited on the inside, and that's called the point bar. So these bends in the river become meanders, and meanders will move. They're not static. They have moved their location over time, and consequently, the river actually moves back and forth across this area that we call the floodplain. And the floodplain is this big flat area where the water goes, and when there's too much water for the channel, it spills over and deposits on the floodplain. And that produces some really good agricultural land. Additionally, when the water spills over, the velocity goes down really substantially. And what happens is sediment gets deposited right on the edge of the river, and that builds up long ridges that are parallel with the stream, and those are called levees. Now, you probably can't see the levees on the stream here because the slope is pretty gradual. You can see some other features. We talked about the cutbank, we talked about levees, we talked about floodplains, but there's another feature over here on this side that is kind of nice, because you actually can see the ice on top of the water, and actually you see a curved surface. And what that is an old meander that was cut off by the stream over here, and now the stream actually takes a shortcut. It flowed around this way, it flowed around this way, and came underneath the bridge and went around over there. But now, because it broke through that meander, it produced this little area that you can just see through the trees that's called an oxbow, and if it fills up with water, it's called an oxbow lake. And right at the moment, we have an oxbow lake developed. And sometimes in areas like Maine, you get these flatter areas up at higher elevation, and you can see them here through the trees. This is a good time to come without there being any leaves on the trees. And what basically happens is when the glacial continental ice sheet came down here like 100,000 years ago, it depressed the land surface. And it took a long time to do that. And consequently, when the ice melted faster than the land could rise up. And what happened was the ocean flooded the southern 1/3 part of the state of Maine. And gradually, over the last 14,000 years, that land has been rising up. And as it's been rising up, the rivers have been cutting down. And what sometimes happens that you can see in the distance here is there's terraces. Terraces develop at different elevations where the stream, they represent old floodplains where the stream used to be, and then the land came up a little further and the river cut down more, and consequently it's been doing that till we got to the point that we're at today. Now the terraces look really similar to the terracing that you see on the lawn in front of Miller Library. But when we think about a stream, we want to see that it's symmetrical. There's terraces on both sides. And along the Kennebec, we can see that without too much trouble. So those are pretty much the features of streams. All right, so I have the luxury of being back in the classroom again. And I waved my hands and jumped up and down out on the bridge, but I wanted to show you this demonstration of some various features of streams. And again, I'm trying to do two things at one time. The stream flow is in this direction, from the top of the diagram to the bottom of the diagram. So at the top of the stream, that would then be upstream, and then this would be downstream. As the stream comes around, these bends in the river are called meanders. And the meanders erode on the outside of the curve, and the outside of the curve there is called the cut bank. On the inside of the curve, the velocity decreases a little bit, so it deposits sediment, and that particular feature is called the point bar. And every time we have a bend, we have erosion on the outside, we have deposition on the inside, and what ultimately can happen here is this particular bend can continue to erode this way, and this particular bend can continue to erode until these two things merge, and the river then flows like this and leaves behind this loop that would either we call an oxbow or we call that an oxbow lake if it was filled up with water. This distance between here and here, that would represent the floodplain down at the bottom, that width. And what you got going on here is this stream moves back and forth in this area, effectively flattening this area out. And so the stream just flows downhill and creates these meanders that move back and forth. So when we talk about this stream, when we go from upstream to downstream, this then would be the right bank, and this then would be the left bank. So that's basically all the things that I talked about out on the trip. So again, you have it here in a form that you can use, and then go back and look at it for reference. So I'll try to merge this in with the other aspects of the Carrabassett Stream field trip so that you have a sort of complete package. Well, welcome to stop number 2. This is completely different. They're taking the old bridge out and putting a new one. This is going to be awesome to work on. Glad I got to see this before I retired. So again, the same stream. This is the place we're a little bit upstream of the Carrabassett Stream from stop number 1. And we'll take a look at the discharge here. This is the upstream view. You can see the current there moving towards me.